In this video, we review an inexpensive option for a point-to-site VPN to an Azure virtual network. Hey everyone, I'm Travis and welcome back to the channel. In today's video, we're going over a low-cost way to set up a point-to-site VPN to an Azure virtual network using a basic VPN gateway. If you're looking for something simple and inexpensive for a lab or a small deployment, this might be an option for you. Before we dive in, if you find these videos helpful, please like, subscribe, and share with a friend or colleague. Let me know what you think in the comments, and if you're studying for a certification or looking to deepen your Azure knowledge, check out my courses on the AZ900, Azure Virtual Desktop, Hybrid Identities with Windows AD and Entra ID, and Windows 365 over at udemy.com. Links are below. And a big thanks to my channel members. I appreciate your support. Now let's talk about VPNs. There are two basic types, site-to-site and point-to-site. Site-to-site connects entire networks together, like your on-prem environment to an Azure virtual network. Point-to-site VPNs, on the other hand, are for individual clients, say a laptop connecting securely to your Azure network over the internet. In my last video, we set up a site-to-site VPN using the basic VPN gateway. This time we're creating a point-to-site connection. To start, it's important to understand what a VPN gateway is in Azure. Essentially, it's the endpoint for a VPN tunnel. Azure offers a variety of VPN gateway SKUs. Higher SKUs come with better bandwidth, more features, and of course a higher price. Some of these SKUs also support availability zones, and Microsoft's planning to retire the older VPN GW 1 through 5 SKUs by September of 2026, replacing them with the AZ-supported versions, the versions that support availability zones. For the demo coming up, we're using the basic VPN gateway SKU. It's the most cost-effective option, but it does come with some limitations. You'll get lower performance and fewer options, especially around authentication. Really, it only supports certificate-based client authentication. I should call out that this setup is really meant for labs, testing, or small-scale deployments. Don't let this example shape your view of the Azure VPN gateways as a whole. The standard SKUs have far more options and are better suited for production environments. One more thing to know, the basic VPN SKU can't be deployed through the Azure portal. You'll need PowerShell or the CLI for that. I've written a PowerShell script that handles everything, and we'll walk through it step by step in the demo. A link to the script is below. To deploy the gateway, we first need a dedicated subnet in our virtual network called Gateway Subnet. For the basic SKU, it has to be at least a /29. Other SKUs require at least a /27. And honestly, it's smart to go a bit bigger to give yourself room to scale later. The script will create the gateway subnet. We just need to provide the IP range. We'll also need a private IP address pool for assigning addresses to clients when they connect. Make sure the IP ranges don't overlap with the virtual network address space the gateway's connected to or any virtual network peered to it. I also recommend avoiding common ranges like the 192.168 range, since those tend to be used on home networks and can lead to IP conflicts. The basic VPN gateway only supports certificate authentication. We've got 3 options to create certificates. Use an internal PKI if one's available, buy a certificate from a trusted CA, or go the free route with a self-signed certificate. That's what we'll use in the example coming up. Again, this is a limitation of the basic SKU. The standard VPN gateway supports certificate-based authentication as well as Entra ID authentication and Radius, so you can hook into Active Directory for a much more scalable setup. We also need a public IP address for the gateway, and here's where it gets a little confusing. Azure is retiring the basic public IP SKU at the end of September 2025. The basic VPN gateway may still require it. That's what we'll use in the demo. However, in the previous video on site-to-site tunnels, I used a standard public IP. So first try it with a standard public IP, and if that doesn't work, try it again with a basic public IP. Anyway, the basic public IP address retiring led some people to think that the basic VPN gateway itself was being retired. That's not the case. The basic VPN gateway is still supported. A link to the basic VPN gateway support statement is provided below. Here's what we're going to walk through in the demo. First, we'll use the script to create a gateway subnet in our existing virtual network. Then we'll deploy the basic VPN gateway. By the way, if you already have the basic VPN gateway in place, maybe you followed along with my last video, you can skip the first step and move on to generating the certificates. After the basic VPN gateway is in place, we'll generate and export a self-signed root and client certificate. Once that's ready, we'll configure the point-to-site settings on the gateway using a certificate for client authentication. Next, we'll move over to the client side. The client VM is isolated in its own virtual network. We'll import the certificate, install the VPN Client software, and test connectivity to the VPN Gateway's virtual network and a peered virtual network as well. Stick around until the end where I share my thoughts on using the Basic VPN Gateway for point-to-site connections. Let's jump in and get started. We'll start the demo by installing the Basic VPN Gateway SKU. The Basic VPN Gateway SKU can only be deployed with PowerShell or the Azure CLI. I created a script that we'll use to deploy the gateway. A link is below. I updated the script from the original version I used to demonstrate setting up a site-to-site tunnel. This new version will remove the gateway subnet, and public IP address if the deployment fails. We need the existing VNet's resource group name, the name of the VNet, and a subnet address prefix for the new gateway before we can create the Basic VPN Gateway. Let's hop over to the portal to get that information. Here we are in the portal at the virtual network we're connecting the VNet gateway to. Central US VNet for this example. We need the virtual network resource group name and the virtual network name. We also need an IP address range for the gateway subnet. Let's go to Setting Subnet. It has to be at least a /29 subnet for a Basic VPN SKU. All other SKUs require at least a /27. The recommendation is to use a larger block of IP addresses. This provides IP addresses for future growth and additional configurations. For this example, the gateway subnet will be 10.25.200.0/24. Plenty of address spaces. Let's go back to Visual Studio Code. We'll also need a name for the new gateway. The comments have the parameter description as well as an example command for the script. Link to the script is below. At the time of this recording, we still have the option for a basic IP address when we deploy the Basic VPN Gateway, but they'll be retired at the end of September 2025. The most common issue is that some subscriptions or regions don't support a standard IP address on a Basic VPN Gateway yet. If the deployment fails, the script will remove the gateway subnet, and the public IP address it created. If that happens, try running it again with the standard IP option set to false. With the standard IP option set to false, it will use a basic public IP SKU instead. Once we run the script, it will verify the required PowerShell modules are installed and that you're logged into Azure. Make sure your account has rights to the resource group to create a new subnet, public IP, and gateway. Also, I tried with an external account that had privileges but got an error. If you see a similar error, verify you're logged into an account that's native to your tenant and that account has rights to add resources to the resource group. It's going to set the gateway subnet name next. That has to be gateway subnet. Don't change that variable. It's also going to use the location of the virtual network. Then it creates the subnet. Next, it creates the basic or standard public IP address. Then it creates the gateway IP address configuration. And finally, it creates the gateway. Let's run the script using the values we collected. It's creating the gateway. This is going to take a couple minutes, so we'll pause here until it finishes. Okay, looks like we got an error for running this command. We've got a status of failed, and the error message is the operation failed due to an error. One or more operations failed. If we scroll up, we can see more information about it. This is likely due to using the standard IP address. So let's let it remove all of the resources that it deployed, and then we'll run the command again, this time specifying a basic IP address. I'll pause here and come back once it's done removing the resources. It finished cleaning up. We'll try running it again. This time we'll specify a basic IP address. And what's really interesting about that error is a week ago when I did the video on setting up a site-to-site VPN tunnel with a basic VPN gateway, I was able to use a standard IP address. I even double-checked the video to make sure. But now on the same subscription and the same tenant, I'm not able to do it. Also, something else to point out, if we scroll up, I do include information in yellow or green or whatever color that is to run the command setting the standard IP to false, as well as some other information. Let's try running the command again. Only this time we'll set standard IP to false. This too will take a couple minutes to finish. I'll pause here and come back once it's done. That finished successfully this time. Now, if we go to the virtual network in the Azure portal, under subnets is the gateway subnet. You may have to refresh. Let's go to the resource group. We can get there from the VNet overview page. It shows our public IP and virtual network gateway. Let's look at the public IP. Here it shows the SKU is basic, and we can also see the public IP address. Let's go back to the resource group, and then into the gateway. It shows our VPN gateway SKU is basic and provides the same public IP address. That is how to create a basic VPN virtual network gateway with a basic or standard IP address. Next, we're going back to PowerShell to create a new self-signed root certificate for the Point-to-Site VPN connection. We're using self-signed certificates because they're, well, free, and we don't have a PKI in this environment. Once we create the root certificate, we'll need to create a client certificate and add that to the trusted store on all the VPN clients as well. We'll do that after we create the certificates. The first block of code will create the root certificate, and notice the not after date. That's when the certificate will expire. You can set it for longer if you'd like. Just know that once it expires, you'll have to go through these steps again. You could update the subject name if you'd like to. For this example, we'll just use P2S root cert. We'll highlight the first block of code and run it to create the root certificate. That created the root certificate and added it to the current user My Certificate store. Next, we'll generate the client certificate. And this is using the cert variable. It's going to work fine as long as we haven't closed the console or changed that variable. If you happen to close the console or change that variable and you need to get it back, you can use this command to reset the cert variable. But we haven't done that. Our cert variable is set. So let's highlight the second block of code and run it. And now we have the client cert. Now that we have the certificates, we need to export the root certificate as well as the client certificate. We'll start with the root certificate. Let's start by opening the certificate manager. Manage user certificates. This is the user certificates. That's where we added the new certificates to. Let's go to user personal certificates. And here we have our two certificates as well as a third we're not going to deal with. We have our root certificate and our client certificate. We'll export the root certificate. So right click on the root certificate, all tasks, and export. We'll go through the export wizard. We do not want to export the private key. Click next. For export file format, we want to select base64 encoded X509, the .cer option. We'll go next. We have to identify the location to store it. So we'll go browse. And I have a certs folder under documents. We'll save it there. Give it the name. We'll give it the same name we named it when we created it. P2S root cert for this example. Click save. We'll go next and finish. It gives us the message it was exported successfully. We'll click OK. And now if we open the folder we exported it to, and then we'll open it with the text editor. I'll use Notepad for this example. That's the certificate value we need for the VPN connection. We need everything between begin certificate and end certificate, not including begin certificate and end certificate. For now, we can minimize this. We'll come back to it shortly. Let's go back to Certificate Manager and export our client cert. This time we'll identify the client cert and right-click, go to All Tasks and Export. Next at the Welcome window. And this time, yes, we want to export the private keys. Click Next. We'll select the Personal Information Exchange. We do want to include all certificates in the certification path, and we can enable certificate privacy. We'll go Next. We have to protect the private key. We'll add a password. And do remember this password, you'll need it coming up. Once the password is entered, we'll hit Next. We'll save it in the same location. Here again, we'll give it the same name as we did the client certificate. P2S client cert for this example, and save. Next, and then we'll finish. And that was successful. We'll click OK. Now if we go back to the file share, we have our exported root cert as well as our exported client cert. Now that we have both the root and the client certificate, we can configure the basic VPN gateway. Before we move on to the Azure portal, let's open up that root certificate again with Notepad or some other text editor. And we're going to copy that value. Remember, we want everything between begin certificate and end certificate. Let's go to the Basic VPN Gateway in the portal next. Here we are at the VNet Gateway. Let's go to Point-to-Site Configuration under Settings. And we'll select Configure Now. If your screen doesn't match mine, try to refresh and go back into Configure Now. We have very few options with a Basic VPN Gateway. It only supports certificate-based authentication. Radius and Enter ID authentication are not an option. We would have to go to a different SKU for that. Let's start by adding a pool of IP addresses that will be assigned to the clients as they connect. The Point-to-Site VPN is limited to 128 connections. So this example will use a /24 subnet to keep things simple. Make sure this block of IP addresses doesn't overlap with any address spaces on the VNets the clients will be connecting to. That will cause an issue with routing. Next, we'll provide a name for the certificate. This is the root certificate we created earlier. And then we have to paste in the data from that certificate. This is the data between the begin certificate and end certificate section. We can add more certificates up to 20. We just need one for this example. If you have a certificate that you want to revoke, we can add that to the revoke certificate list. This is for certificates that have been invalidated before the expiration date. If we want to invalidate a certificate we no longer want to use, for example, we could add the name and the thumbprint here. Next, we can advertise additional routes. For example, if we're using service endpoints with a public IP address that are only available from the private network, we could add the public IP address here. That would force traffic to that public IP address through the tunnel. If the VPN Gateway's virtual network is peered with other virtual networks, you don't need to add the peered virtual network address space. That's added automatically. Let's save. Saving can take several minutes. We'll pause the video here and come back once it's done. That took a while, but now the configuration is saved. We have the point-to-site connection in place. We're ready to move on to configuring the client. Before we go to the client computer, let's download the VPN client from the point-to-site configuration page. This is what we'll use to connect. The client's specific to our environment and could take a minute to download. That's finished. Let's go to the download folder. Let's copy the zip file to our client workstation. The zip file has the same name as the VPN gateway. Here we are on the client workstation. Let's place that zip file into the download directory. And we'll extract it. And we'll go into the folder. Let's take a look at what's inside. There are 4 folders that include a Windows 64 and 32-bit installer, as well as a PowerShell install script. If we open the folder labeled generic, this folder has a root cert and the VPN settings.xml file. Let's open up that XML file with Notepad. This file includes certificate information, as well as information about the IP address configuration. We can also see the address space for the primary and peered virtual network. If we modify the VPN gateway, we have to download a new version of the VPN client and update each of the client workstations with the new information. Now that we have that downloaded, let's configure the VPN client on the workstation. The first step we need to take care of is adding the client certificate to the client workstation so it's trusted. We need to take this step because we're using a self-signed certificate that's not trusted by default. If we had a PKI or purchased a certificate from a trusted authority, we wouldn't need to take this step. We'll get started by copying the client certificate to the client, not the root certificate. Let's go back to the configuration workstation, the one we created the certificates on. Here are the certificates, both the root and the client cert. Let's copy the client cert to our client workstation. Once we have it on our client workstation, we'll double-click on the certificate to open it. Leave it set at current user and click Next. Leave the location and the file name. Keep it as a .pfx. We'll go Next. Enter the password we gave it when we initially exported the certificate. We can leave the rest default, go to Next. Leave the location set to automatic and go Next. And at completing the certificate import wizard, click Finish. We can click Yes at the security warning. It looks like that was successful. Let's click OK. If you'd like to see where those certificates are imported, we can open up Manage User Certificates. Under Personal, Certificate, there is the client certificate. And if we go to Trusted Root Certification Authority, Certificates, scroll down, there is the root certificate. We can close that. Go back to the download directory. Now that we have the certificate in place, we can install the VPN client. Open up the extracted VPN Client folder. That was the one we copied over earlier. Open the client you'll use, Windows 64-bit for this example, and we'll run the executable to configure the VPN client. We can dismiss the security scan. We'll click yes, and that configures the client. Next, we'll open VPN under Network and Internet Settings. Open up the connection. The connection name matches the virtual network the VPN gateway is attached to. And we'll select Connect. That brings us to the setting page where we can click Connect again. And just to verify, we'll hit Connect one more time. It does prompt us that we need to run this with elevated rights, so we'll click Continue. And we're connected. Let's test connectivity with the ping command. Let's minimize the VPN connection and open a command prompt. We'll start with a test server that's on the same virtual network as the gateway. The IP address of that test server is 10.25.0.4. And that works. That's on the same virtual network as the VNet gateway. Next, we'll ping a test server that's on a peered virtual network. The address space for that is 10.30.0.0. The server is at 10.30.0.4. And that works as well. So we're able to ping a server that's connected to the same VNet as the gateway, as well as a server that's on the peered network. Let's go back to the VPN gateway in the portal. Here we are back on the VPN gateway. Let's go to Monitoring and then Point-to-Site Sessions. And there it shows our active connection. That is how to deploy a basic VPN gateway, create self-signed certificates, and use those certificates to configure a point-to-site connection on the VPN gateway, as well as the client workstation. That's how to deploy a basic VPN gateway and use it for point-to-site connections in Azure. Now, I've got a few thoughts on point-to-site connections with the basic VPN gateway, but I want to stress that this only applies to the basic SKU, not the Azure VPN gateway service as a whole. First off, it's a solid option if you're learning how VPNs work or if you're setting it up for a home lab. For production though, I wouldn't recommend it. Managing self-signed certificates at scale is a hassle. If someone was to leave the organization, you'd have to revoke and reissue certificates to prevent unauthorized access. And while you could generate unique certs for each user, that adds even more overhead. But the biggest issue, you need local admin rights on the client to connect. That's a deal breaker for most enterprise environments. The standard VPN gateway SKUs offer more flexibility and secure client options that are better suited for production environments. I hope this helps you better understand how point-to-site VPN connections work with Azure Basic VPN Gateway. Thanks for watching, and I'll see you in the next one.